Spark streaming and sliding window analytics. Preface. Content of this lecture. In this lecture, we will discuss real-time big data processing with Spark streaming and sliding window analytics. We will also discuss a case study based on Twitter sentiment analysis using streaming. Big streaming data processing. The motivation of going for streaming data processing is deep rooted and is based on the motivation is based on the applications such as fraud detection in different banking transactions which are happening online and the real time how this particular fraud detection can be done. That becomes a challenge. So therefore, this motivates streaming data processing system and how using that we can do this online or in a real time the fraud detection in the banking transactions. Another such application which has motivated the use of streaming data processing is detecting the anomalies in the sensor data. Now you have seen that lot of IoT deployments are happening these days which basically collects the sensor data and then based on these sensing data the anomalies are to be detected in real time. This also has given the new way of solving these problems using the streaming data processing in real time. Similarly, we want to do the analysis of tweets and based on these analysis we can find out the sentiments or the mood of the people at a particular instance. So this online in a real time this tweet analysis also requires the streaming data processing. So these applications or newer applications are now given a reason to think of providing streaming data processing for analysis for analytics in the real time, and therefore we are going to understand the new concepts and the very new theory that is Spark streaming, how that is being used in today's workload and the newer applications. Now the question is how to process the big data, big streaming data. So now here we are going to deal in this part of the lecture the data which is called streaming data. So if the stream of the data is very fast and also a continuous stream, then it is categorized under the big data scenario, wherein this particular characteristic which is called a velocity requires the infrastructure of a big data to handle it. So that means we require hundreds to the thousands of these nodes to scale that means to scale out to deal with this fast data, which is also called as the streaming data. So for the scaling and scalability and for we require hundreds of nodes to process this big streaming data. Another aspect is about achieving the low latency. Obviously, this requires the insight into the technology. We will see how we can achieve the low latency in this streaming data processing framework. Now, another requirement is about how to deal with the failures and how to deal not only with the failures, but how to efficiently recover from the failures, so that it can be tolerated by the applications which are monitoring in the real time the events and for different applications. So, we have to deal with the failure recovery, which is to be done, so that it can be it can cater to the application in a real time applications which are based on streaming data. Now, another thing is that now there are various interactive processing is happening with the streaming data, and this particular streaming data is also called as a fast data. Now, besides this fast data, sometimes we also require to integrate with another stream of batch data. So, if there are two different modes of data, that means one is through the batch data, the other is called streaming data. Together, there are some applications which requires the integration of both these different type of data, and they are different, and they are having a different stack to be processed. So, how are we going to integrate them? In the traditional, in the previous the technologies, they are having a different stacks, and therefore, the integration is basically time taking and may not be useful for real time applications. So, here we are going to see the new technology which is called the Spark streaming, which will combine or integrate this requirement of processing simultaneously the batch and the interactive data. Now, let us see how what people have been doing so far. That means, what are the other systems before this Spark streaming, and how it was being done. So, actually, as we see that for batch processing and for stream processing, there will be requirement of different stacks, and often different stacks are optimized for different type of data. So, integration is not very common in the previous generation of systems. And for example, for batch processing, we have the Spark system, and we have the MapReduce framework for doing the batch processing, and for the streaming in the earlier systems were such as Storm. So, now integration requires two different stacks to be combined together. So, hence it requires it has a lot of latency involved within it, and may not be sufficient for different real time applications. That is why this particular framework, which we are going to discuss in today's lecture, that is called Spark streaming, which will integrate both batch and streaming applications using the same stack. Therefore, it will be the most efficient way of dealing with multiple type of data, that is the batch data and the stream data, when they are required to be processed at the same time. So, the existing framework such as Storm and MapReduce cannot do both of the processing, that is for the batch and the streaming data at the same point of time. So, either the stream processing of hundreds of megabytes with a low latency, or the batch processing of terabytes of data with high latency, are to be dealt separately, and the combined or integrated viewpoint is not available as of date before this Spark streaming. So, Spark streaming is the new technology which we are going to discuss, and we will be also seeing different use cases where this kind of batch processing and stream processing together are required in many applications. So, therefore, it is required to maintain two different stacks if the integration is not supported, and also they may require different programming models, and also different efforts are required, and also requires an operational cost. So, that is not feasible. Therefore, the Spark streaming we are going to discuss today how that is all integrated and is being useful for various applications. Now, let us see before going in more detail about the Spark streaming. So, how we will see, let us see that how the fault tolerance is achieved in the stream processing systems. So, traditional processing models use the pipeline of different nodes, and each node maintains the mutable states, and each input record updates the state and the new records are sent out. Now, the problem with the previous systems were that the mutable states were lost if the node are failed, and this is a norm. Failure of the nodes is a norm rather than exception. In the commodity hardware. So, therefore, when the node fails, the mutable states which are maintaining this fault tolerance for the mutable states will be lost. So, some things are basically lost which are in the traditional, the previous systems. Therefore, the stream therefore, making the stateful stream processing fault tolerant is also very much needed, and in Spark streaming system we'll see that how this stateful stream processing is done and in a fault tolerant manner. Now, let us see what is a streaming. So, data streaming is a technique for transferring data so that it can be processed as a steady and a continuous stream which is incoming to the system, in a stream of data which is incoming to the system. So, you can visualize as if the data is flowing continuously on the pipes, and as it passes through these pipes, it has required to be processing in a real time, and if that is there, then it is called the data streaming or a streaming data. Now, the sources which generates the streaming data are many. For example, the internet traffic which is flowing, also if it is seen, then it will also be a network streaming data. Similarly, the Twitter streaming data also can be taken up in some of the applications. Similarly, the Netflix which is in a real time online movie watching, that also generates the streaming data. Similarly, YouTube data also a kind of the streaming data, and there are many other ways this streaming data can be generated. Streaming data can also be generated from the database. So, data is read and is being transmitted in the form of the streaming data, that is ETL. So, companies normally does this for the analysis. So, streaming data technologies are becoming increasingly important with the growth of the internet and the internet enabled different services which are available in the form of Netflix, Facebook, Twitter, YouTube, Pandora, iTunes, and so on. There are tons of such different nowadays services available through the internet. Now, let us see the Spark ecosystem, and we will see the positioning of the Spark streaming system where it lies. So, from in this Spark ecosystem we will see that on the core there is a Spark engine, and on top of it is, you can see that Spark streaming system is running. Now, the Spark streaming system runs over the Spark core, and this enables the analytical and interactive applications for the live streaming data. So, therefore, these core components of the Spark framework provides the utilities and architecture for the other components also. Therefore, dealing with this Spark streaming over Spark gives many other advantages. For example, the analytics which is required to be performed on the streaming data may sometimes need the machine learning on that to be applied on the streaming data. Now, with one single common stack, that is a Spark core engine, it is now possible that we can apply, or it is possible that the machine learning libraries which are built on top of the Spark can also be used for analytics of the streaming data. Similarly, the graph processing applications such as graph computation engines, which combines data parallel and graph parallel concepts, can also be useful for the analysis of or analytics of the streaming data, and they are all integrated. Similarly, the Spark SQL, which is also the structured way of accessing the key value store, can also be useful to be used in the Spark streaming for storage and the retrieval purposes. So, therefore, having the same stack, this Spark streaming will gain a lot of advantages, not only for doing the batch processing and the streaming data together, they can be integrated, and a lot of other that means libraries can be used, such as machine learning can be applied for the streaming analysis, and graph also can be used as for the streaming data analysis, which can be represented in a graph and can be done analysis. We will see this Spark ecosystem. So, the Spark streaming, the positioning on top of the Spark core will gain lot the advantages of other such utilities like machine learning, that is MLlib, GraphX, Spark SQL, and so on. We will see in further slides how we are going to utilize the integration of all these together in solving today's workload problems. So, what is Spark streaming? So, Spark it extends the Spark for doing the data big data streaming processing. So, big data stream processing can be now done with the help of Spark streaming, which is an extension which extends the Spark core to perform this Spark streaming. Now, this Spark streaming project was started in 2012, and it was released in the form of this Spark 0.9, and Spark streaming has a lot of built-in support to consume the data from different sources, such as from Kafka is also one of the receiver which can feed the live stream data to the Spark stream. Similarly, Flume, Twitter, 0MQ, Kinesis, and TCP/IP sockets are some of the inbuilt receiver system. Through APIs, they can be plugged into the Spark streaming system to get the stream data for computations in this scenario. So, in Spark 2.x, a separate technology based on the data set called structured streaming has been designed, and that has a higher level interface provided to provide the support of streaming. So, let us see the streaming Spark streaming framework for a large scale processing of streaming data, and we will again let us review that. It should be scaled to the hundreds and thousands of the node. It can achieve second scale the latencies. So, that means latencies are to be in the form of seconds. So latencies are in the scale of seconds, not in the minutes, or not latency should be in the minutes or hours and so on. Now, achieving this is the scale of seconds. Latency is not going to be easy task, and it requires the new design. Therefore, we are going to understand the Spark streaming system. Now, this Spark streaming system also integrates the batch and the interactive processing together with a unified view with the same stack. Therefore, with unification on this batch and interactive application, it is now possible to achieve the latencies in the scale of seconds. Similarly, it will provide simple batch like APIs for implementing the complex algorithms, and it can also integrate it with the live data streams from different other tools such as Kafka, Flume, ZeroMQ, and so on. So that is why this Spark streaming is nowadays required very much. Now, Spark streaming receives the data stream from different input sources, process them in the cluster, and push it out to the database's dashboard for its output. Therefore, Spark streaming is a scalable, fault tolerant, and having the latencies of the scale of the seconds time. So let us see through this particular diagram that the inputs, the data can be received through different input sources. So it can be received either from Kafka, Flume, or SDFS, Kinesis, or Twitter. This live stream of data is now fed into the Spark streaming system for the computation of streaming data computation. And after that, the output will be either stored on the database or it will be pushed on the dashboard for the output. So we will now see in this part of the discussion what is the Spark streaming, how it is handling this kind of streaming data of different sources together, and for which is useful for various applications. So therefore, again we are going to understand about why the Spark streaming. So many big data applications need to process the large data streams in the real time, such as website monitoring sometimes is required to see the loads, the hits which are basically coming on the website, and whether the performance of the website is going well or not has to be monitored. Similarly, the online transactions for the bank or for the credit card also needs to be analyzed in real time. So that becomes a streaming data applications. Similarly, various ad monetization also require to be processed in real time. So whenever a user clicks on a particular ad, and so those ads are to be so when the user will click, so all that data, the click through data has to be analyzed in real time, and therefore different ads are to be pushed in that manner. So the Spark streaming is very much needed, and many important applications must process large stream of live data and provides the results in a near real time. Near real time means this particular system which we are going to discuss, that is Spark streaming, has the latencies up to the half of the second. So those latencies which are tolerable up to half of the seconds can be used here with the help of Spark streaming. Even lesser than this can be used in a separate streaming systems which are known as the Storm and so on, which has very less latencies. already available. So, let us see that if the different applications such as social network trends, website statistics, intrusion detection system, and so on, they need this kind of streaming system and require the large cluster to handle these workloads, and also require the latencies of the order seconds. So, we can use the Spark streaming to stream the real time data from various sources like Twitter, stock market, geographical system for doing the powerful analytics. So, Spark streaming is used to stream the real time data from various sources like Twitter, stock market, geographical systems, perform powerful analytics to help various business. So, therefore, there is a need of a framework for big data stream processing that scales to the hundreds, thousands of the nodes, achieves second scale latencies, efficient to recover from the failure, integrate with the batch and interactive processing. Let us see how what are the different features which are able to cater all these parts. So, Spark streaming features, first is the scaling. So, Spark streaming can easily scale to hundreds and thousands. So, speed also is low latency, and fault tolerance is achieved here to recover from the failure. It is also integrated with the real time and business analytics is also supported. So, let us see another part besides the integration with the batch and the batch processing and the real time streaming data processing. Other than that, we will see another requirement which is about stateful stream processing. In the traditional model, as we have seen that it provides a pipeline, and if the mutable state is lost, then it has to handle. So, let us see the modern data applications approaches for more insights. So, traditional analytics is basically require these kind of analysis. Now, the existing systems for the streaming data analysis is called a storm, and it replaces the record if not processed by the node, and therefore, sometimes it provides the at least once semantics. So, that means some of the updates, if the mutable states, the nodes are failed to achieve the updates in the mutable state. So, that means it will update twice. So, that becomes a problem in at least one semantics, hence the mutable states can be lost due to the failures. So, this at least once semantics and will create problems in some of the times where the updates are to be done twice, and in the existing systems like Storm does achieve only up to that state of the art, which is called at least once. So, exactly once is the semantics which is required, and it is supported in the Spark streaming system. There are other streaming systems such as Trident, which use the transactions to update the state, and there also has exactly once semantics, and per state transaction to external database is slow. Now, how does this Spark streaming work? Let us understand this. So, it runs a streaming computations as the series of small deterministic batch jobs, and the live streams which are taken up or which are considered in the system is to be divided into the x seconds, and the Spark treats each batch of data as an RDD and process them using an RDD operation. Finally, the processed results of RDD operations are returned in the batches. So, let us see all these things using the diagram. So, here the live stream data, when it is entered, it will be divided into the batch of x seconds, and this particular Spark streaming system will now divide into the batches, and these batches in the form of RDDs will be given to the Spark engine for processing, and the process result will finally be emitted. So, again let us discuss this entire scenario, which says that to run this Spark streaming system requires the streaming data to be entered into the system, that is called data streams. Data streams are received by the receivers of the Spark streaming system, and then it will divide into the batches of x seconds, and they are called micro batches. Or a micro RDDs. So, after dividing into the batches of x seconds, this particular micro batches will be given to the Spark, and Spark treats each batch of data as RDD and process them using the different RDD operations which are provided by the Spark engine. And finally, the process result of the RDD operations are returned in the form of batches and will be taken care, either they are to be stored in the database or they are stored in HDFS or they are output on dashboards. So, there are different ways this output can be, or the result of this Spark streaming can be now used in different applications. So, therefore, we have seen that to run Spark streaming computation as a series of very small deterministic batch jobs, and these batch sizes are as low as half of the second. So, it cannot be lesser than half a second latency. Why? Because this is to be set by the system. So, latency, if let us say batch size is a half of a second, it will finally end to end latency, it comes out to be only 1 second. So, therefore, seconds of latency is achieved due to this batch size of half a second size is being computed and processed. So, therefore, the potential for combining batch and streaming data processing in the same system exists. Why? Because finally these batches are also micro batch RDDs, and which are given to the Spark system, and the batch data also is processed to the Spark system. So, finally they have the single engine, that is the Spark engine, which process both the batch as well as the streaming data after the processing of the Spark streaming. So, therefore, it is possible to combine or integrate both batch processing and streaming processing in the same system. And now let us see an example of a word count with Kafka as the live input source, and how this is all done in the Spark streaming system. So, this word count application, we can see we have to create the Spark streaming context, and with a 1 second size of batch sizes, and the Spark and then this particular context will be bound to the Kafka utilities, and which will give the live stream in the form of lines, and this particular line will be further processed by the Spark streaming using flat map, which will split this line into the words, and this word will now be applied on a map function. So, map function is doing the transformation on all the words which will be received by the Kafka live stream, and this map function will now perform the transformation, that for every word it will emit the word and a value 1, which in turn will be taken reduced by key, and for every word it will now try to count, or it will now do the sum of all such words appearing number of ones. That means, and therefore every word will now have a particular count which will be printed, and then we have to do this context start and finally the context await termination also. So, you see that word count with the Kafka is quite easy to understand, and you can write down the program, and rest of the things, that is the entire operation of this stream computation is completely abstracted from the user. Now let us see the internal details of the Spark stream execution. Before that, let us understand first the Spark application. So in the Spark application, that is Spark engine will have the processing in the terms of the driver program, which will now communicate with the executors running on different nodes onto the cluster systems, and this particular driver will communicate to the executor, and this particular driver will assign the task sent to the executor for processing this particular data. Now this particular driver launches the executors in this particular cluster, and this can be done with the help of Yarn and Mesos or Spark standalone clusters. So this way the Spark launches using the driver program, and driver and executors. Driver will assign the task to the executors, and executor in turn will perform the execution of the processing of data in the Spark system. Now Spark streaming runs on top of Spark engine. So let us see how the Spark streaming application will now progress in this scenario. Again, there will be a driver program, and the same word count program which we have written is given to the driver, and driver will now in turn runs the receiver as long as running the task. So these particular tasks are given to the executor, and executor in turn will have the receiver which will receive the live data stream from Kafka. So after receiving the data from the Kafka, now the data will be this particular live stream data will be received in the form of lines, and these lines will be now done in and that will be in the form of data blocks. Now then it will assign the task of a flat map on these executors. These data blocks are to be replicated on to the other executor. So replication also is required for achieving the fault tolerance of these data blocks. Now further, the driver will also assign the tasks to be performed by the executors on these data blocks, and for example we have seen the flat map and performing the map reduce operation on the word counts. All these tasks will be executed at the executor. So all these are the components of the Spark streaming system. So here we see that how it will receive the data using the receiver, and then we have also see that how the data will be processed. So each batch interval the driver launches the task to process these particular data blocks, and these processing will now give the results to the results back, and that result will be stored in the data store. So these parts we have seen, and now we have also seen internally how the data is to be processed in the Spark streaming Spark streaming system. So let us review the entire scenario as the Spark streaming architecture. So it is based on micro batch architecture, operates in the interval of time. Whenever a new batch are created at a regular time interval, it divides the received time batch into the blocks for parallelism, and each batch is a graph that translates into the multiple jobs and has the ability to create the larger size batch window as it processes over the time.